Hello Math 1 students, this is standard 1.I, which is adding and subtracting polynomial expressions, right? Before we can add or subtract polynomial expressions, the one thing we have to understand is the idea of what a like term is, okay? And like terms are basically terms with identical variable expressions. And an example of this would be 3x and 4x. These are like terms because if I look at the variable expression, x, they're the same. If I look at, say, negative 6n and 5n, those are like terms. Now, examples of unlike terms, these would be unlike terms, would be something like 5x and 6y. Now, when we go to combine like terms, all we are doing is adding or subtracting the coefficients of terms with identical variable expressions. So when I look at the first example here, example 1a, right? I've z to the fourth, z to the fourth. Right away, I'm just going to add the 5 and the 3 together, and that gives me 8z to the fourth. Now, example b, right? Although I don't see a number in front of m to the third, right? I have to picture it as being negative 1 m to the third. So I'm going to read this problem as negative 1m to the third plus 2m to the third plus 6m to the third. And now when I add negative 1 plus 2 plus 6, this is going to give me positive 1 plus 6 will give me 7m to the third. And I am done. But the third example here, if you look, right, there's more than one pair of like terms. So what I always do is start with the highest exponents, right? And I'm going to put a box around the x squared. What else can I put a box around? The minus 6x squared. I always include the sign to the left. Now I can put a circle around 2x. What else can I circle? 12x. Then I can underline negative 5. I can underline positive 8. Now, anytime we do this, when we go to combine like terms, we basically add or subtract the coefficients of terms with identical variable expressions, but always write your final answer in standard form. Okay? And that is important. So right away when I look here, the first thing I'm going to do is the x squareds. So that is 4x squared minus 6x squared. 4 minus 6 is negative 2x squared. So negative 2x squared. So once I get negative 2x squared, then I work towards my x terms, right? Oh. So right next to this 2x, right? So 2x plus 12x will give me 14x. Since it's positive, I'm going to add it. Cross it out, I'm done with them. And then negative 5 plus 8 will give me 3. So that's plus 3. And we are done. Okay? And if I look, this is all written in standard form. Highest exponent to lowest exponent. Now, when we add polynomials, all we are basically doing is dropping the parentheses, and then second is we combine like terms. Okay? So right away I drop the parentheses and I get 5x squared plus 7x minus 4 plus 3x squared minus 6x plus 2. Now, I drop the parentheses, and when I go to combine like terms, I have 5x squared can be combined with positive 3x squared. Then I have 7x combines with negative 6x, and then negative 4 combines with 2. So now when I go to combine them, I start with my x squareds. 5x squared plus 3x squared gives me 8x squared. So 8x squared. Cross them out, I've used them. Then 7x minus 6x, remember I always include the sign to the left, will give me 1x, so it's plus x. And then last, negative 4 plus 2. Negative 4 plus 2 is negative 2. Since it's negative, I'm going to subtract it. And this is my final answer. Okay? Try the next one on your own real quick and come back and check your answers. So I'm going to go ahead and drop the parentheses. So 2x to the 5th minus 2x to the 4th plus x to the 3rd minus 1 plus x to the 4th minus 3x to the 3rd plus 2. Once I go ahead and drop the parentheses, now I'm going to look to combine like terms. What can I combine with 2x to the 5th? There are no other 2x to the 5ths, so I move on. What can I combine with x to the 4th? Right here. Now, x to the 3rd gets combined with negative 3x to the 3rd. Oops, that was the wrong color, right? So, can I do this? Sorry, I'm just going to rewrite that. So, plus x to the 3rd minus 3x to the 3rd. If we switch colors, x to the 3rd goes with minus 3x to the 3rd, and then the constants get added. So, right away, I have nothing to combine with 2x to the 5th, and I always start with the highest exponent. But now, negative 2x to the 4th plus x to the 4th, that gives me negative 2 plus 1 is negative 1x to the 4th. Since it's negative, I subtract it. Cross it out, I've used it. Now, 1x to the 3rd minus 3x to the 3rd will give me negative 2x to the 3rd, and I'm going to subtract it. And then negative 1 plus 2 will give me positive 1. And I am done. Okay. Now, next, when I go to subtract polynomials, the first thing you have to understand is I have to distribute the minus sign. Once I distribute the minus sign, then I basically combine like terms. So right away, when I look at the first example here, I'm going to distribute, when I distribute a minus sign, it's like distributing. So right away here, so when I look at my first example, the first thing I'm going to do is drop the parentheses. So I get 2a squared plus 3a minus 1. But in the second one, I have to distribute basically a minus 1 or a negative 1. When I do that, a negative times a positive 4a squared is going to give me minus 4a squared. What you have to understand in the next one, negative 1 times negative 5a, a negative times a negative is a positive 5a. Then a negative 1 times a positive 6 is minus 6. Once I drop the parentheses and distribute the minus sign, now I can combine like terms. So 2a squared goes with negative 4a squared. 3a goes with plus 5a. And then minus 1 goes with minus 6. So right away here, 2a squared minus 4a squared. 2 minus 4 is negative 2a squared. So negative 2a squared, cross them out, I've used them. Then 3a plus 5a gives me 8a. Since it's positive, I add it. And then finally, negative 1 minus 6 is negative 7. So minus 7. And I am done. So basically remember, whenever you get done or whenever you approach a problem, ask yourself, do I have to distribute anything? If no, then I drop parentheses and combine like terms. If yes, I distribute and then combine like terms. So the next example, do I have anything to distribute here? No. So I write it down. 5t to the third minus 3t squared plus 2t minus 8. But in the next quantity, what do I have to distribute? This minus sign. A negative times positive 4t to the third is negative 4t to the third. A negative and a positive here would be minus 2t squared. And a negative would make that a plus 3t. Once I'm at this point, now I combine like terms. Okay, the t to the thirds go together. The t to the seconds go together. The t's go together. And the constant goes together. So over here, 5t to the third minus 4t to the third gives me 1t to the third. Since it's positive, I'm going to keep it positive. Now, negative 3t to the second, right, minus 2t to the second. Negative 3 minus 2 is negative 5t to the second. Since it's negative, I'm going to subtract it. Then 2t, right, plus 3t would give it 5t. So plus 5t. Then I have nothing to combine the minus 8 with, so I bring it down. And I am done. So the next examples are pretty much kind of like what I would consider honors level problems. Remember, round parentheses, close round parentheses, square brackets, close square brackets. So right away here, I have nothing to distribute here. So I'm going to bring this down. Negative 4m squared plus 3n squared minus 5n. But before I can distribute this minus sign, I have to simplify what's in here. So I'm going to simplify this part over on the side. So I drop the parentheses here, so I get 3m squared minus 5n squared plus 2n, but then I'm going to distribute the minus sign here. So minus 5m squared minus 4n. When I combine like terms here, 3m squared minus 5n squared minus 5n squared is going to give me 3 minus 5 is negative 2, minus 5 is negative 7m squared, and then 2n minus 4n is minus 2n. So when I look at this, now I'm basically subtracting. What does that bracket become inside now? Negative 7m squared minus 2n. So now what I have to do is distribute this minus sign. So negative 4m squared plus 3n squared minus 5n. But now distribute this minus, a negative and negative make that positive 7m squared. And then a negative 2n becomes a positive 2n. So now I combine like terms. What can be combined with m squared? 7m squared. So negative 4 plus 7 is 3m squared. What can be combined with n squared? There's nothing, so I bring down the 3n squared. Now, negative 5n plus 2n gives me minus 3n. And this is my answer. Okay? And the last one. First thing I'm going to do is simplify what's in the brackets here. So that right there, I'm going to distribute this minus sign. That's going to become negative 4m squared. That's going to become plus 8m. That's going to become minus 4m to the third. I'm going to distribute this minus sign. So it becomes minus 3m squared minus 2m minus 5m to the third. Then I have my plus m squared out here. Now, once I do that, I'm going to combine like terms inside here. Negative 4m squared, negative 3m squared. I have 8m, negative 2m. Then I have negative 4m to the third. It's supposed to be blue. Okay, so I'll just box this. So negative 4m to the third goes with negative 5m to the third. So right now in this box, once I combine like terms, I can drop the brackets. So I'm going to start with my highest exponent. Negative 4 minus 5 is negative 9m to the third. Then I go to my next exponent. Negative 4 minus 3 is minus 7m squared. Then 8 minus 2 is plus 6m. And then I have this plus m squared on the outside. So now when I combine and simplify this, negative 9m to the third. When I combine negative 7m squared with 2m squared, that's negative 6m squared plus 6m. And I am done.